What's up, guys? Welcome to this video. In this video we are going to go over So You Want to Be a SOC Analyst Part 2 by Eric Substack. I'm going to link his vlog, very informational. In this specific video though, we are going to generate our C2 payload. We're going to generate a C2 session payload, and we are going to then run commands on our Ubuntu server and see how Lima Charlie it's another EDR solution that we're playing around with. I think last video we were playing with Open EDR. This video we're playing with Lima Charlie. We're going to see all the telemetry that's generated. We're going to see the alerts that are created there that we are able to see, query for. And yeah, all that fun stuff. We downloaded, we have our Windows 11 VM ready. We have our Ubuntu server ready. We ran some commands like who am I, Pwd, and let's see how all of that appears on our Lima Charlie EDR. We're kind of gonna follow this blog post. I haven't used Lima Charlie to its full extent. I'm learning as we go. I just kind of wanted to make a video, explore, get more familiar ourselves with some more EDR solutions. You can never go wrong with that. So here, Eric tells us to generate our C2 payload. We have already done that. The name of our C2 payload is long hello. So it generates different code names for everybody, just so that we can differentiate between payloads. So we executed it on our Ubuntu. Here we have the session. We can go to sessions, and we see that it's alive. We see our host name, the WinDev, how we discussed our last video. And we ran some commands. We ran who am I. We ran a whole bunch of commands on our WinDev machine via the payload. So now we can start we already did our session. We ran our info who am I, get privs, pwd. We ran all that fun stuff. And now we are going to observe the EDR telemetry that was generated. So here it tells us to go to sensors and click our host name. This is the walkthrough, by the way. We're not going to be using this for right now. So we are here at our overview, and let's go to processes. So here it says go to processes, and we get to see all the processes, the user that it was run and under, the path, the full path. We get to see the command line, the specific commands that were ran, the PID, the PPID. Something interesting we can check is on our Ubuntu server, the payload that was created is called long_hello.exe. So what if we search for that? We get it right away, and we get to see view network connections. Are we able to see view? Oh, okay, super interesting. So we get the name of the process, what was executed, under what user, the path that was used to execute it. We did download it into our user downloads folder, and the command that we just executed. So we get to see our source IP and the destination IP, the protocol used, and the state established. We saw that it was alive. So that's super fun. We get to filter for specific executables and see what they are communicating with. So this recommends to spend a few minutes exploring the process tree, all that fun stuff. It recommends getting familiar with the normal, so we're able to identify what's not normal, the abnormal, the evil executables that are not supposed to be on our machines, on our endpoints. So next, what we're going to do is click on the network tab. We're going to go here to our network tab. This is super interesting. We see the processes, the IP, the IPs that they're communicating with, and the hashes. So this is what if we grab the hash from this long hello exe and run it through VirusTotal. No match is found, and that is completely fine, and even makes it a bit more suspicious because how Eric Substack's vlog says, we can read it word for word. While it says scan with virus total, what it's actually doing is querying virus total for the hash of the exe. If the file is common, well known, malware sample, you will know it right away. However, item not found on virus total does not mean that the file is innocent, just that it never been seen before by virus total. This makes sense because we just generated this payload using Sliver's the Sliver C2. So of course it's not likely to be seen by virus total. This is an important lesson for any analyst to learn. If you already suspect a file to be possible malware, but VT has never seen it before, trust your gut. This actually makes a file even more suspicious because nearly everything has been seen by virus total. So it just makes sense to explore the hash, explore the executable a bit more, look into it, considering that virus total has not seen it. So what could possibly, what is going on? So that is super interesting. And then it recommends us to go to file system. So let's follow this file system, and this is super interesting. We're able to see all the files, just how let's say we SSH into the system, we're able to see all the files. We're able to go to the root directory. That is super cool. Let's see what it says. Browse the location we know our implant to be running from. So our implant is running from users, user downloads, long lexe. We are able to inspect the hash, copy file path, move the file, and delete the file. Oh, this is super interesting too. We're able to explore the hash directly from this EDR solution. That is super cool. So I didn't even need to open a new tab and enter virus total, search it up. It just did it automatically. That is super fun, super convenient. So browse to the location we know, inspect the hash. Okay, we inspected the hash. We already talked about this a bit. So now it recommends to go to the timeline on the left server menu of our sensor. This is nearly real-time view of our EDR telemetry, event logs streaming from the system. So let's go to our timeline, and this is all that's happening in real time. Everything that's happening in our system. We see network connections, DNS requests. This is super cool. Can we see when our executable long underscore hello? Can we search for that? Right here. Process PID, the command line. Oh, this is super cool, dude. We're able to click on the log and see the IP address. We're able to see the event ID, the host name, the time. We get timestamps. We see if it's signed or not, the path, command line, what was executed. This is super cool, dude. Super convenient. And the filter option makes it even more convenient. If we see a process that we're not necessarily sure of, we can get the timestamp, search the hash, do all that fun stuff. So it recommends to read the docs, practice filtering your timeline with known IOCs, indicators of compromise, such as the name of your implant or the known C2 IP address. Oh, we can even search up the IP of the RC2. If you scroll back enough, you should be able to find the moment your implant was created on the system and then it was launched shortly. We kind of did that, checked the time it was ran, the process, the executable. So now it says spend more time exploring Lima Charlie Telemetry to familiarize yourself not only with the known bad events, but also the abundance of normal things happening on your idle Windows VM. Even clean systems are very noisy, so familiarizing yourself with that noise will pay dividends in your career as an analyst. In the next post, we're going to get back into our Sliver C2 session and do some more insidious things to generate telemetry we'll use to craft our first threat detection rule. So in this video, just to kind of wrap it up, we generated some and observed our telemetry in our EDR solution generated by our C2 session, ran some commands, we executed the payload, and we got to see how all of that looked under the timeline tab, under the process tab, network tab. We got to see even the file systems that were seen on the Windows 11 host. Here also receive we get some information. So yeah, we got to see all of that convenient fun stuff, and on our next video we are going to finish this lab, and how Eric told us in the bottom, we are going to craft our first threat detection rule, play a little bit more with our Sliver C2 session, and overall familiarize ourselves with managing alerts, creating those detection rules, querying for this telemetry, you know, finding information we want to find out, finding what's weird, what doesn't look right, what doesn't belong. And that's about it for the video. Thank you guys for watching.